In today's video, I'll be walking you through on how to write the target value to the Balluff BDG 0291. Here in front of us is a Balluff Ethernet IP master BNI 006A, and next to that is the BDG 0291. And as we know, as the position changes, we'll get our feedback of the position. And you'll notice that the green and the red of the outer circle changes depending on how close we are to this lower value, which is the target value. So by default, the target value is 0, and by default, as long as I'm within 10 units on the plus side or 10 units on the negative side, I will be in what the device tells us that we are on target. So this is, again, all the default settings. Now, our goal here is to adjust the target value based on using a MSG message instruction within the Rockwell software. So that will be the video here, is how to set up a message instruction within the Rockwell environment to write a value to that target value in the BDG device itself. So on the Rockwell side, in my I/O configuration here on the bottom left, I've already added the BNI 006A Ethernet IP master. I just called it Balluff Master, and I've created the AOI for that. I've got my move instructions to move a 1 or 0 into the port functions to set the I/O link port as I/O link or as standard I/O. And I've already added the AOI for the BDG 0291 in its legacy format. Now, all of this already being done has no bearing on the message instruction, but I just wanted to show you that this is some minimal logic I've already got set up. One of the things I forgot to show you was I'm going to come back here to my live view, and the BDG is plugged into port number 4 of my I/O link master. So that's going to come up of knowing that I'm plugged into port 4. On our Ethernet IP masters, the ports are numbered. This is an 8-port master, ports 1, 2, 3, 4, and then 5 through 8 down the right side. So let's start by looking at the manual for the BDG. The target value here, I need to note that it has an index and a sub-index value. The index value is 520 decimal, but since I'll need to break that up into a low byte, high byte value, I'm going to concentrate on the hex equivalent. So the hex equivalent of the decimal 520 is a hex value of 0208, where 02 is the high byte and 08 hex is the low byte. The sub index is 0, and this parameter is has 4 bytes. It's 4 bytes long. So I need to know that as I set up my logic here. So I'll be setting up the logic online with live editing. So we'll first set up the message instruction. So I'm going to type in, or I'm going to add an XIC, a one-shot, and then the message instruction. We'll create some quick tags here. I'll need to toggle the BDG, if I can spell, target value. And I just want to one-shot the message instruction. So I'll tag out my one-shot. And then I've got to give a name to my message instruction. So I'm just going to call it what its function is, right? BDG target value MSG. All right, so basics of the logic here. I'm going to toggle the bit and it will fire the message instruction. To configure the message instruction, we'll click on the ellipse button here. And in the Rockwell environment for the Balluff masters, we're going to use a CIP generic. Service type is custom. Service code is always going to be 36. Class is always going to be 96. The instance is the IO-Link port number, and previously I pointed out that we are plugged into port number 4. Attribute is 2. That is telling this command it is writing. If the attribute was 3, it would be reading. Now, how many bytes of data am I going to send to the device? Well, we saw earlier that this parameter is 4 bytes long. Now, when I send this message instruction with those 4 bytes of data, I also need to send the index value, which is 2 bytes, and the subindex value, which is 1 byte. So I'm actually needing to send 7 bytes of data. So I'm going to bump this source length to 7. So again, 4 bytes of the actual value of the parameter plus an additional 3 that'll hold the index and the subindex value. So I'll use this new tag function here, and I'm going to create the source element array. So I'll just call this BDG target source, and it needs to be that length of 7. So everything's in bytes, so that's short integers within the Rockwell environment, and I need to send 7 bytes, so we'll make a short integer array of 7. I've called the tag BDG target source. I'll then bring in this value, or bring in this array, BDG target source. I'll bring in the first element of this message. And then we'll create a new tag because I do need a destination array. So we'll call this BDG target destination. And when I write to a IO-Link parameter through the Balluff master, if the value is bogus, meaning that it's out of range or the wrong size, the message instruction will not error out, but the device will send back an error code. And if it does send back an error code, it needs a return bucket of memory of a short integer array of 5 elements. So this is to capture any errors coming back from the IO-Link device if there is a problem with the data that you sent it. So BDG target destination, short integer array of 5. I'll bring that in. There's my BDG target destination, and I'll bring in element 0. And then lastly, we'll come to the communication tab. I'll click browse. There's my Balluff master from the IO configuration that I've added earlier. We just need to highlight it and choose it. So now I've got my path. I've got the message configuration set up. So the message now is done. For the sake of the video, I'm going to, through some move instructions, show you how the values are needed, how the values are going to be configured for the 7 bytes we're going to send out, if that made any sense at all. So again, this is visual. You don't have to do it this way, but I like doing this just so I know exactly what I'm feeding into the data that I'm sending out to the message instruction. So we had 7 bytes in this BDG target source array. So I'm going to make the array of the 7 elements. It's going to be my destination for all 7 of these instructions. So for each move instruction, we're going to just go through the source 0 through 2. And again, that's my going to be my subindex and my index value. And then 3 through 6 is going to be the actual target value that I'm going to send out. Now the target value is going to be a double integer, but I have to send that double integer value out within a 4-byte array. So let's fill in the sources here. So the first 2 bytes that I need to send out in byte 0 and byte 1 is the index value. Again, the low byte is 08, the high byte is 02 in hex. So byte 0 is the low byte. So I'm going to type in 16 pound to denote that my value is in hex. So that's the low byte here, so 16 pound 08. And I'll put in 16 pound 02. That is the high byte. And then the sub index is a 0. So I'll just keep consistent and put everything in hex, so 16 pound 0. So my index, sub index, and then somewhere within your ladder code, you're going to have a double integer tag that'll actually be that target value. That's the 32-bit word. That is the value that we want displayed on the BDG device. So we're going to take this target value and we're going to break it down into the 4 bytes. So I'm going to use the bit field distribute instruction to do that. Now, we need to know where in this 32-bit word that we need to start moving the 8 bits from the target value into my 8-bit short integers. So I made a little cheat sheet here to show you that it's a little backwards, but this is the way we're going to have to send the data out. So byte 3 in the message is going to contain the target value starting at bit 24. Byte 4 will start at bit 16, byte 5 will start at bit 8, and finally byte 6 will start at 0. So in my ladder code here, we're going to start from the target value. 24 is going to go into byte 3, 16 into byte 4, starting at bit 8 into byte 5, and starting at bit 0 for byte 6. My destination bit, my destination is a short integer or a byte, so we're moving all 8 bits into that. So we're going to start at the bit 0 of these bytes, and we're going to move 8 bits. So this will take my double integer and break it into the 4 bytes that is going to be sent out through the message instruction. So this is the way it's set up. Please rewind the video as much as you need to notice my cheat sheet here of how to break up the 32-bit value into the 4 bytes that need to be sent. Finally here, we will accept my edits, and we'll do a split screen here. And what we'll note here is that my target value is 0. I'll put in a target value of 100. And we will toggle the message instruction. And as we see on the display there on the right, the target value is now 100. And if I adjust this to get within 10 units of 100, we will be on target. And of course, I can change this target value to maybe a -20, and we'll toggle this message instruction again, and we note that the target value is now changed to a -20. So this is how to write to the target value within the Rockwell software using a Balluff Ethernet IP master and the Balluff BDG device. Thank you.